Hey guys, welcome to something I've never really done before. One of my hobbies is coding, so I've recently finished my first big coding project, so I figured I'd show it to you guys. And what it is I've been trying to learn a bit of Japanese recently, just because I like learning languages. I already know some Russian, so it seemed like a pretty cool thing to do, and I started this back when I first started learning Python. So over time, I have added what I've learned, and it's slowly become more and more uh, workable to the point where I feel like it is actually helpful to use and really intuitive to use. So, as you can see, it uses some kind of advanced things. I guess it writes to files, it reads files, stuff like that. So I'll run it real quick. I just gotta open the title. So it opens this first menu. I can practice kanji, hiragana, or katakana, and I can see my high scores. So now practice kanji. Then you can choose what grade you want to start at, or you can submit a custom level, 7 to 2136, which is the number of kanji. I think there's 6,000 something total kanji, but 2136 is, I guess, the decided upon normally used kanji, I guess. So, for example, start at 7, I'll go to 12. Ask me what it is. Okay, I got it right. 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 And that gives me my percentage grade, my letter grade, and my time. It also calculates your high score and stuff like that. So it's very useful, I think. And in total, it is 955 lines of code long. It took me a really long time to get this finished. I spent multiple hours just staring at this, trying to figure out what was causing a certain bug or something. And it's always like, oops, it's always one number that's off or one line that's off. So I figured I'd just go through the code in its entirety and show you guys what it is. It seems a lot more complicated than it is, but it is kind of long. So yeah. Also, this gray blob right here, I have an eye tracker, and that's where I'm looking right now, so you can see where my eyes are at the screen, which is pretty cool. So first of all, this is running in the shell. The reason that I did it in the shell is because I'll show you. If you just try to run it here, let's say I want to do this, I want to do grade 1, you can't see the Japanese characters in this window, which is obviously really important. There might be a way to do that, but I couldn't find it, and I don't know how, so I just settled for doing it in the shell. Um, but it's for somebody that doesn't already have Python. If I want to distribute this, it would be a bit harder to set up, but I put in this README right here how to do it. So it starts off with importing all these modules and stuff. Time is just block things, so if you want to take down the time that it currently is, you can do that. And random is for any RNG. Codex is really important because uh, it can't read, or no, I'm sorry, text files, which is what I'm storing everything in, can't save Japanese characters unless it is in a different codec from normal. So I had to import a codec and read it with that codec, which took me forever to figure out. I just thought I was doing it wrong, but no, it's just the codec. So yeah, and I'll show you what these files are. High scores, just list high scores. There's a 0 here. This is kind of messed up because I was just testing it, but it's fine. And the hiragana is just a massive list of all of the hiragana characters. Hiragana.defs is a list of all the definitions of the hiragana characters, and these are exactly synced up. So if I open this, this character is A, so the first definition is A, and it's synced up all the way to the end. Kanji is the same thing, except it's way longer. So it actually extends to the horizontal limit of Notepad like 4 times. So it is really, really long. And kanji defs is the same thing. It syncs up all of the words, which is going to be very useful later. And katakana and katakana defs, the same thing. Back to this. First, the set variables. These are things that I don't need at the moment, but I will need later. For example, loops. I use that in a couple while loops and I think one for loop. If I don't set it to 0, or if I don't set it to something to begin with, it'll just error out. So these are everything that I set to something just to make sure there's a placeholder there. 2137 is in there a couple times, and that is one more than the number of kanji. So if I use 2137, it won't get in the way of anything else. And the reason that these numbers are what they are, I'll explain when we get to them later. So the first thing that this does is get your file and get the last slash in the file path. So if I just save this file as something on my desktop, and I print file with 2 underscores on either side, it will give me the path of the shell that it's running from. And I use this to make sure that you can run my program from anywhere you put it on your computer. And also, if I put this on the internet and somebody downloads it, their path will always be different because the full path, I closed that other one. Yeah, I did. So open this real quick and run it again. So the path includes the username of the person, and nobody's username is going to be mwolf, unless for some reason it is, but this will not work unless I change that. So what this bit of code does, is it takes file, which is this, and says last slash is equal to the first slash character from the right, so that would be this, and then root equals file last slash plus 1. And what that does is it takes everything up to that slash and sets it as the variable root. So what that means is I can say favicon is equal to root plus favicon.ico, and that means that whatever this is plus favicon.ico. So no matter what username you have, it will always redirect to the proper file. And I did this with every single file in that directory, so you can place the program, or at least the folder the program's in, at any spot in your computer and on anybody's computer, and it will still run. And here is just importing all of the files that I showed in this folder. As you can see, I had to use UTF-8 encoding, which allows for Japanese characters. Kanji txt.read. The .read function actually reads the file. You can load it in, but in order to read it, you have to use the read function. And hiragana.split. The .split function splits the it splits the text file into a list, and it splits it by whatever character is here. In this case, it's a comma. So if I go back to my hiragana file, all of these are separated by a comma. So what that hiragana.split parenthesis does is it makes everything an object in a list called hiragana, and every object is separated by a comma in that text file. So now, instead of this, it creates a list out of it that I can actually use in the code. So going back, I had to do that with all of the options, which is kanji, hiragana, and katakana. High scores was a little bit different because I'm not doing the same thing with high scores that I am with all of those. But after that is the functions. Functions are little bits of code that you declare at the start of the program, and once you want to execute, say, this bit of code, I would type later, click katakana parentheses, and it would come back up and execute this bit of code. So I won't go over these now, but I'll go over these when they come into play later in the program. And there are a lot of functions. This whole block of code is still a function. Click H cheat sheet. There's another giant block. So a lot of this is blocks like that. So the first thing that actually happens in the code that the user can see is that it opens up this window. This is the very first window you see. So this is this. Move this to the side, oops. So every button on this window has to have a line of code. So this button has this line of code, this one has this one, etc., etc. And the width is self-explanatory. But command is actually what the functions up above are. So this command is click kanji, and that's what happens when I click this button. Click kanji is a function that's declared up above, so when I click it, it's going to see command is click kanji, and it's going to go all the way back up the code to click kanji, and it's going to execute this code. So there are a lot of buttons in my code since I have a few different windows. So once you click kanji, it will set which one to kanji, and then it'll close the window. Window.destroy closes the window. There is a window.close function, but for whatever reason it doesn't actually close the window as far as I can tell. So maybe I'm stupid, but I don't know. And global, what that does is in a function, if I say a equals 1 or a equals 2, once I leave that function, the computer forgets that. And a only equals 2 in this function. So what global does is it sets whatever variable is after it to be that set variable everywhere in the code. So if I did global a equals 2, the entire code would know a equals 2 instead of just this function. And here is the variable which one. I use that I believe 3 times throughout this code. So let's see, where was I? Yeah, so this is the first one, and if you hit kanji, it sets which one, the kanji, and that would signify that the user has chosen which one they want to practice. So that's why I named it which one. And if you hit the button kanji, this if statement is true and it executes everything for the kanji section. So let's say I do select click kanji. It then takes me to this window, and this is the most complicated window that I made. Well, actually the second one is more complicated, but pretty much the same. So it's where do you want to start, and you can choose from 7 grades, or you can submit a custom starting location. The grades, what that means is, I looked this up, and in Japan, kanji is learned in grade schools, obviously. So in first grade, you would learn a certain amount, second grade, a certain amount. So that is what these mean, and S is secondary school. That's what that stands for. And 7 to 2,306, or sorry, 2,136. There are 2,136 total kanji. I believe there's actually 6,000, but the agreed upon normal everyday use kanji is 2,136. And I'll get to why it's 7 to this number later, but yeah. So it's pretty cool. This took me a long time to figure out. The documentation for TK Enter, which is what I use to create the windows, is very confusing, and I had to look up a lot of tutorials for it. But I eventually got it to work. So again, every single button has a line of code, including this title that has a line of code, and this where do you want to start is a line of code. But the text box is a bit harder. It's 2 lines. So text entry 1 equals the text box. And then it displays it in the grid. I should mention that these windows are displayed in grids. So if I want this button to be here, I can't do that because the window is 3 rows long, or I'm sorry, 3 columns long. And that's how TK Enter works. Everything is in a grid. I could code it to not be in a grid, but then I would have to learn more stuff besides TK Enter, and it'd be way harder, so I just stuck with the grid pattern. And I don't think it looks too bad anyways. But that is what, where was it? Yeah, that is what this is. So row 6, column 3. Row 6, this counts as a row, so 1, 2, 3, 4, and this blank. I intentionally made a blank row for aesthetic purposes. So 1, 2, 3, 4, 5, 6, and column 3, 1, 2, 3 is the text box. And then you have to connect the submit button to the text box. There's no default option to have a submit button. This is just a normal button like all the rest of them, but it's tied to the submit box. And it does that through the function it runs when it's clicked. As you can see, the command is click submit. So if I go back up, here is the click submit function. It declares these 3 variables as global. And yep, so all of my windows are labeled. Before every window pops up, I have a variable named current window. And if a specific window pops up, I assign a number to it and call it current window. So that window is 2. So if window 2 is the current window, starting level will be equal to text entry.get, and text entry is the name of the text box. So it gets whatever text you put into it, and it makes it equal to starting level when you hit submit. And I also have is custom here, and this is pretty important because if I click through here, if I put in a number here, then all of these buttons are not options anymore. Because I'm already doing a custom range, in the next window where I choose what point I want to end at, I don't need any of these options because the program should already know that it's a custom range that I want. So is custom is marked, I believe, as soon as, yeah, so No, that's not it. One of the downfalls of having a long code, it's hard to find stuff. Is custom. Oh yeah, it's declared here. Okay. So is custom equals true. If you click the submit button, that means that you have a custom range. Because if I click any one of these buttons, it automatically goes to the next window. I don't click submit. So if I type something in here and I click submit, that means it's a custom range. So when this function runs, is custom is now true because it knows that it's a custom range that you want. And is custom is also declared way up here as false. So by default, you are choosing a non-custom setting. Is custom is only turned on once you hit the submit button. So going back down here, if is custom equals true, it'll display this window. If it's not true, it'll display this window. And they're completely different. So let me just hit that real quick. So if I type a number in here, let's say 100, I submit, the next window will not have any other buttons but the custom range function. So if I X this out, I run this again, I choose Kanji, I choose grade 2, it doesn't have the custom range option because it already knows that you want a default option. And another thing, I X this out again, I want to do Kanji. If I click grade 5, all of the ones before grade 5 are, I can't click them. This is because if you start at grade 5, you can't end at grade 1. You can't go backwards, you can only go forwards. I could make it so that you can go backwards, but that's just redundant. Instead of doing grade 5 to grade 1, you can just do grade 1 to grade 5. It's much easier and it makes more sense. But also, these buttons that don't do anything are also specifically coded to not do anything. So, as you can see, this button here, yeah, so this line of code is this button. And it's just like a normal button. It has the text that I want to put on it, the width, but the command is click and null. So it runs the function click and null when I hit the button. And if I go up, click and null, I should probably just do this. Click null, the only thing it does is nothing. Pass just means do nothing. I have to put pass there because you cannot have an empty function. You have to have something in there or it'll give you an error, so putting nothing in there, which kind of makes sense, I guess. Here I was. Open this window again. And all of these also have an info button and a quit button. So if I hit quit, it quits the program entirely. And I'll run it again. I want to do kanji and I want some info. So if I click info, it'll give you info about the kanji quiz. And if you want to read this, you can. But I'm gonna move on. And yeah, info and quit, these are both functions again. So what click info does is it just prints a bunch of words, and click quit closes the window. I also used click quit for a different window, but the thing is, let me find it. You cannot close multiple windows with one function. So if I do quit the first window, that's fine. But if I do quit the second window with the same quit function, it's not going to work. So what I did is I used the current window variable that I declare before every window opens, and I say if uh, if this specific window is active, close that specific window. So all of my windows are named window with a number after it. The only reason current window is different from this number is because with current window I forgot to start counting from 0. I just counted from 1 instead. So that is confusing, and it confused me too. I spent a lot of time trying to figure out why my code wasn't working, and it was just because I put in 1 instead of 0. So going back, there I am. And lastly, the last different thing that this window does is if you hit grade S, and it does nothing. Haha. Okay, that's a bug. Well, what it's supposed to do is to just close that window and give you grade S. I'm gonna have to fix that bug after I finish recording this, but if you want to start at grade S, you can't go up from there. The only option that you have to end on is also grade S, so it doesn't open the second window. And also this wait window is very important because, well, what this does is it executes all this and it waits for the window to be closed and then it moves on. If I don't have this, then as soon as I open the window, my entire rest of the code starts going. But the problem with that is that the rest of the code needs what the user inputs in the window in order to operate. And because of how fast the code goes, if I don't put that there, the code will finish before the user has put in anything. So it's very important to have that wait window. So the next part is starting level and starting index. So for a moment, I'll go back to another button here. So for example, if I want to start at grade 3, that goes to click grade 3. And what that does is it makes starting level equal to the string 3. I should mention that if you don't know, words are called strings, numbers are called integers. So 3 like that, that's an integer, but 3 like that is a string. Basically, if it's between 2 quotation marks, that makes it a string. So now that starting level is equal to 3, my code will go down here, and it will start looking at these if statements. So if starting level is equal to 1, well, it's not equal to 1, it's equal to 3, so it moves on. If starting level is equal to 2, it's not equal to 2, it's equal to 3, so it moves on. If starting level is equal to 3, it is equal to 3, so I'll do this, and I'll make starting index 240. This is important because I have a variable, well, it's not a variable, it's a list called Kanji. And in that list, Kanji has every single symbol in it. So if I want to start at symbol 200, I put in 200, and the way that it gets the kanji to quiz you on is it sees what position is that in the list of kanji. So I'll give you a more visual example here. If I click on kanji, so 1, 2, 3, 4, 5. Let's say I want to start here. So I put in the number 5 for where I want to start. And what the program does is it takes the number 5 you put in and it checks, okay, what's at the 5th position in this giant list, and that would be this. And then let's also say that I said I want to end over here. I think that's 2, 3, 4, 7, 8, 9. So this is 11. I input 11, and the code says, okay, you want to start at 11, so the farthest kanji we should quiz you on is what is in the 11th position of this giant list. And using that, we know the 5th position is the starting point, and the 11th position is the ending point. So the program quizzes you on anything that's between 5 and 11, and that's works. But starting index, the index is what position in the list, and that's just the definition of index. So why have two variables here instead of just using starting level? The reason for that is because of the grade feature. If I open, oh, I don't have the window open. Oh, never mind. And that's because of the grade feature. So if I hit grade 1, that sets my kanji number to 1. Or it doesn't, sorry, that was wrong. It sets starting level to 1. If I hit grade 2, it sets starting level to 3. But if I enter a number here, whatever number I enter, that's what starting level is set to. So that's the reason why this is 7, because 1 through 6 is already taken. So starting level 1 is a default. If you click the grade 1 button, it will set starting level to 1. Starting level 2 is a default, 3, 4, 5, 6, and S is a default. I think that's probably gonna show that. Go down a bit. Let's see, where is, oh, here it is. So all of these are defaults, and if starting level is not equal to any of these, it will make the index equal to the level. So if I go back, this window here, if I go back into this window, if I type something in here from 7 to 2136, if I type in 70, starting levels will be equal to 70. It's not 1, it's not 2, it's not 3, it's not 4, it's not 5, it's not 6, it's not S. So it must be something else. Starting index is equal to starting level, so now the program knows where in the giant list of kanji to look for the ones that you want. And it does the exact same thing for the ending level. I don't know why this is double indent. It doesn't really matter, it just bothers me. So next is the high score. I'll open the file that has the high scores in it to show you. This is a giant list of all of the possible things that you could be scored in. Wait a minute. Huh. Oh yeah, I just restored. Okay, so this is an old version of this file, so I'll just fix that real quick. This is the one that I was testing with. And the one that I originally intended to use got accidentally deleted. So this is also a good look into what exactly this text document is. We're gonna visual. We're gonna full. That's a Kana individual. That's Kana multiple. Save that. Anyways, these are all the possible things that you could be scored in, and 999 is a really bad score. The test is not scored on how many you get correct, but how fast you do it. Because eventually, once you learn all of the symbols, you're going to stop getting them wrong, but you still want to practice them. So this program isn't really intended for learning the symbols, it's more intended for practicing them. That's why I use the time limit. And all of these scores are measured in seconds. So this is 999,999 seconds. And even if you're the worst player ever, you're probably going to get a better score than this many seconds. So this is the default. So if it says your high score is 999,999, you know, okay, that's a default. So back to the code, high score line. So if starting level equals ending level, this is checking if you've only selected a single grade. So if I select my starting point as grade 1, my ending point also as grade 1, then I've only selected a single grade. So if that single grade is grade 1, then high score line equals 2, and what that means is, let me go back up, is that is line number 2 in this text document. So computers start counting from 0, so, or no, sorry, that was wrong. For whatever reason, in this specific case, it starts at 1. Don't ask me why, I have no idea. But, so this is line 1, this is line 2. It wants to see what the high score is for grade 1, and that is indeed grade 1. And it does the same thing for all of these. And over here, if your starting grade, or I'm sorry, if your starting level is 1, and your ending level is 2, meaning you clicked start at grade 1 and you clicked end at grade 2, it goes to here, grades 1 to 2, and chooses that score. So high score line is just choosing which score should be the high score for whatever you're doing at the moment. I believe I have high score line set somewhere, but I don't think it's, oh yeah, I set it in a function up above, which isn't coming to play yet. So here is setting the current high score. So in this section, it learned, okay, what line of the text document should I read to know the current high score? And in this one, it actually reads. So current high is nothing. That means, well, it means exactly what I just said. It sets the current high score to be blank. There needs to be a blank here because in order to put in a score, you have to have somewhere to put it first. So high score bank is high scores.readlines. This variable high scores, that is this text file. So high scores.readlines is this text file reading every single line. And that is equal to high score bank. And what readlines does is it splits every line into a list. So the next line for x in high score bank, for x in, what that means is the code does something however many times. So let's say, I'll just do an example for this, so I have a blank thing here, okay. So list is equal to 1, 2, 3, 4, 5, or 1, 2, 3, 4, whatever. For x in list, print mwolfe is cool. And it prints it 4 times. So for x in list, it does this for however many things are in this. So in this case, it does this for however many things are in this. Now these brackets are very simple. So I'll show another example for that. Oops. So list brackets 2 is equal to 3. So what that is, whatever you put in the brackets is the certain position something's in this list. So it starts counting at 0. So 1, 2, or sorry, 0, 1, 2, and that's a 3. It comes back with a 3. So all brackets are is a certain position in that list. In this case, it's high score line -1. -1 is just there because, again, I did one part where I started counting from 0, and I did one part where I started counting from 1, and it just totally messed everything up. So this is a very bootleg solution to that, but it does work. So, and remember, high score line is a number. So number minus number is a number. Everything in this bracket is equal to a number. So it'll look for that number position in the list that is high score bank. So going over all that again, high score bank is equal to, or high score bank is a list of every single line in this text document. And then for X in high score bank, add the number high score line -1. So what that does is, we'll just, for up here, let's say that my high score line is 48. So I go to high score line 48. I'm not going to count out the lines, but let's just say it's this. This is line 48. So for X in line 48, X just means for everything in this. So there are 6 numbers in this line, so it will do this 6 times. So what this does is it checks, okay, is that specific character a number, and or is it a dot, because it measures high scores to the 10th of a second, so like 10.7 seconds. So the dot is also considered. And if it is either a number or a dot, then it does this. Current high is already up here as blank. Current high is blank. So right now I'm reading this line. It goes to this character and it says, okay, is it a number or a dot? Yes, it is. Now let's do this. Current high equals current high plus X. X is equal to whatever it's looking at the moment. So whereas current high is currently nothing, it will add X to it, which means it'll just add a 9. And it'll do this for every single character in that line. So it'll assess this character, and if that meets the requirements, it'll go in current high. And it'll assess this character, and if that meets the requirements, it'll go in current high. And does that for all of them until it has, until it's done with all of the characters. So after that, it now knows that current high is equal to this. And that is the current high score in seconds. So from here, we now know that current high is equal to the high score. After that, it closes the text document. I could have done this differently. Later in the code, it needs to be open, but I closed it here just so that I could, help myself make sense of it. So after that, it prints grades. So these red letters, anything with a pound sign before it, I refuse to call it a hashtag. Anything with a pound sign before it is ignored by the code. So these are just notes for me. So right here is the section that I call print grades. And it says, okay, you have chosen this grade, and it tells you that. This is for if you only choose to do one single kanji. I figured I should probably code in. So that's all this is doing. And here is begin timer. This is from earlier. What line 628? Okay. So this is from earlier when I said import time. It's gonna take me forever to find 628 again. Yeah, okay. Oh. There we go. So this, what this does, it basically takes down what time it is. And it takes this down in, I believe, 60ths of a second. So if I go into my example thing here, that is the current time. I believe this is in 60ths of a second. What is this number anyways? Thousand, million, billion. I believe that that is the number of seconds from July 1st, or no, January 1st, 1960. I think that's how computer time works. It's kind of irrelevant, but uh, your computer doesn't actually measure the time in AM, PM, hours, minutes. All it has is the number of seconds between right now and I think it's January 1st, 1960. I could be wrong on that, but it's some old date when they first incorporated time in computers. And then it turns that into this clock. So that's just your irrelevant factoid of the day. So it takes that. You cannot have a timer in this code. So what I do is I take the time here, and I take the time at the end, and I subtract them to find out the difference. So right here is where it actually begins questioning you. And this is like 3/4 down, so that's pretty interesting. But this is where it actually starts the questions. So right here it just gives you some instructions on how to answer the questions. Right here is just a double check to see if the level you chose to end at is higher than the level you chose to start at. It should be impossible to do, but if someone were to do it, it would give an error message instead of actually working, which is intentional. And that's what this is. It's a custom error message. So questions. I wanted questions to be the number of questions that you had to answer, so it's ending index minus starting index. The total number of kanji in between these two is the number of questions. And so this is a while loop. What a while loop does is it says as long as whatever this is true, then keep doing everything under it. The moment this turns false, then it stops doing all this. So loops is another thing that I coded way, way up at the top. And what I said up at the top is that loops equals 0. So every time it completes a circuit of this highlighted code, at the end is loops equals loops plus 1. So if loops is 0, loops equals loops plus 1, loops is now 1. And that keeps track of every single time, or I'm sorry, that keeps track of how many times this loop has been gone through. And this loop is what asks you the question. So I don't want more questions to be asked than there is kanji to question you on. So if I select 20 kanji to be questioned on, I don't want 30 questions. I want 20 questions. If I didn't do that, then it would error out. So as long as questions asked is the same thing as how many questions I want, it'll keep asking questions. This here is how it knows what questions it has asked you and what questions it hasn't asked you. So let me just no. Go back to this. So if I select I don't know, this range that I want to be questioned on, and it has already asked me all of these, how does it know to question me on this one and not one of the ones that is already asked me? So I have a list here called already done. And what this is every time it asks you a question, it keeps track of the place of that symbol in that massive list of kanji. And if you get the question correct, it puts that number into the list already done. And every time it asks you another question, it checks already done for that number. And if it's there, it picks a new number. If it's not, it asks you the question. And every question is randomized. If you choose a certain range of kanji, it'll be in a completely random order that it asks you the questions. And I wanted to do this intentionally so that you can't just memorize the order of the questions, you have to actually memorize the symbols. So random.randint. Random is another thing that I had way up there. I imported random. So kanji number is the number in the list of giant kanji. Or the place of the symbol in the list, giant list. And every time it randomly picks between these two. So it picks between where you want to start and where you want it to end. It picks something in between there that is not already done, and it asks you that question. So it prints what is, and then kanji number, question mark. And remember, this variable kanji equals this text document. And whatever's in brackets is the position of this text document. So if it's position 4, it'll be 1, 2, 3, 4. It'll ask me this kanji right there. So moving on, it asks for your answer. And if your answer equals that of the definition of the kanji, it gives you a correct. And it does that because earlier I mentioned this file, kanji defs. So let's say I'm doing kanji number 4. 1, 2, 3, 4. Notepad. There we go. So it goes, okay, we're questioning you on number 4. And it says, is your answer equal to the 4th term in this list? And if it is, it's correct. If it's not, incorrect. And if it's correct, it just says correct. And if it's incorrect, it counts the number of incorrect questions you got and it tells you the right answer. And this is what it does if it tries to ask you a question that it already asked. It'll, oh wait, no, I'm sorry, I'm thinking of something else. Yeah, so if you get a question wrong, it's not going to answer, or it's not going to ask you the same question that you just got wrong. It'll pick a new one. So this is picking a new one. And then after that, and this while loop up here stops once you've answered all of the questions. And right here, I call the function ending calculations. So that's way up here. Ending calculations. So what this does, end time, it calculates how much time it took in these two lines. It calculates what percentage of the questions you got right. And it calculates how many minutes and seconds you spent on it. It also calculates how many minutes and seconds the current high score is, because the high scores are stored in seconds, so it has to convert that back to minutes and seconds. And formatted percent is formatting the percent to a whole number. So usually this will not be a whole number, so this just makes it a whole number. And this line is very important. If starting level is over 7. So, let's see, yeah. So, 7 is important because that is where the default range ends and the custom range begins. So, basically this is saying if you're doing a custom range. And I'm not going to have high scores for every single range because that would be probably like a million different numbers that I would have to store. So if you're doing a custom range, it doesn't ask for the high score because there is none. Going back. Here we go. And here it just tells you your results. You took this time, you got this many incorrect, your percentage grade was this, and your letter grade was this. Yeah, so is it PB? Stands for personal best. So this is, it checks if your high score is higher or lower than the score you just got. And if the score you just got is better, then this is true. And I believe later, let's see, I can't remember exactly where I put it. But anyways, it gives you, if you beat your high score, it says congratulations, this is the new high score. It beat your last score of blank. You didn't beat your high score, it says, sorry, you didn't beat it, and this is your high score. After that, it calls the function high score overwrite. And again, that is only if you got a new high score. So let's go back up. Functions, high score, overwrite. This probably took me the longest time to code out of anything here because the documentation on this is just terrible. It's really hard for me to read the actual Python documentation just because it uses so much jargon that I have no idea what it means. So I usually try to go to like Stack Overflow or forum websites, and all of them give different answers because the way to do this has changed throughout time. So anyways, this took me forever. Basically what it does is it says total seconds. Yeah, so this converts minutes and seconds back to seconds so it can store it in the high score text document. And high score bank, high score line -1, that is just which line in the high score document do I store this to. This opens the high score document and this writes it. And then it closes the high score document. We're going back down, we'll continue on. Yeah, so here it is. This is what I just looked at. And after this, it gives you some more information about how good you did or how bad you did. But then this part of the code is if you instead choose to be quizzed on hiragana. I'll run this again, and this time I'm going to choose hiragana. And it'll give me 3 options: individual, multiple, and use cheat sheet. Individual quizzes you on each individual symbol. Multiple quizzes you at multiple at once. It's kind of self-explanatory, but use cheat sheet opens this handy window, and then I can have this open while I do the quiz. And if you've never seen on a table, this is what it looks like. So let's say I want this Kana, that's K and I, so that's K. So I want this Kana, E, and that is E, so that's P, etc., etc. And you can open as many of these as you want. I was going to try to limit it to one, but the code for that is kind of complicated, so I decided just to leave it because it doesn't really matter that much. But from here, it does the same thing as the previous menu. So if you hit individual, it sets which one to individual. And if which one is individual, then it starts this and it quizzes you on individual. Hiragana and katakana quizzes, individual ones, are very, very similar to the kanji quiz up above. So I won't go over that because it's pretty much the same thing. But the multiple is different. So I'll do an example of the multiple. Kana cheat sheet. So here we go. This is my sentence and I have to translate it. This doesn't actually say anything. This is just gibberish. It's just like very loosely meant to simulate what it would be like reading an actual Japanese sentence. So I'm not very good at hiragana. In fact, I mainly go to this for kanji. I know 350 kanji now, but I haven't started on hiragana yet, so I'm probably gonna do that soon. But as of now, I actually can't answer this question. But I can look on my handy cheat sheet here. Let's see. It is a bit hard to read because the text is small. I can't change that, unfortunately. That's just the way it is with TK interface. But anyways, I'm just gonna not answer that and move. Oh, here we are. So this is the multiple, and the thing about coding this is that it was very hard because you have to display multiple symbols at once. I also want it to seem like they're different words. I don't want it to be 10 symbols in a row. I want it to be, 2 5-letter words in a row. So I had to find out how to randomly generate a space in between all of the symbols at a random interval. And I keep losing my spot, I'm sorry. Okay, here we go. So it starts off with the same thing, loops questions for x in range 20. Range 20 just means do it 20 times. So there is not, you can't choose certain Kana to be tested on. There's just 20 questions, it's concrete. So right here, this just chooses a random number between 1 and 10 and makes it equal to is space. And if is space equals 3 or 4, so if this random number between 1 and 10 is 3 or 4, and I can't remember how I did this. Can it be space loops equals 1? Oh yeah. So if I go way back up here, can it be space is this seemingly random string of ones and zeros. So I'll take a little clip of this so I can have it with me down when I roll. Yeah. Oops. So the thing is, I don't want there to be a space as the first character because that makes no sense. I also don't want there to be a space as the last character because that also does not make any sense. So what this does is, can it be space is this string of numbers, and it tests if the position of loops in canopy space is equal to 1. So let's say I'm on my third question. Wait, no, I'm sorry. Man, this even confuses me. This took me forever to figure out. So, for every letter that's generated, it tests if it's a space or not. Random number between 1 and 10. If it's 3 or 4, it has the possibility to be a space, but it also has to satisfy this condition first before it actually puts a space there. And this condition is it a 1 in this string of numbers? And the first and last two are not 1s, so I will never have a space in the first and last two characters. I also don't want 2 spaces in a row, because that's just nonsense. So, where did I set this? So, if it does do a space, was last space is now true, and when it tries to do another space, it tests if was last space is true, and if it's not, then it's okay to do another space because it knows that there won't be 2 spaces in a row. This line here randomly generates a Kana, and Kana string is the 10 Kana long question that you get. And the rest of it is basically like what it is above, except instead of just one Kana, it's multiple. And that is kind of the last complicated thing that there is. The next bits, everything I'm scrolling through now, is katakana, and the code is exactly the same as hiragana. I won't really go through that. But the last thing that you do, and this is part of the very first menu, is this see high scores button, and if I press it, it just shows me the high scores. And that is the last thing. I did that in 972 lines of code. I thought it was 965. I was wrong. Yeah, that's pretty much it. I spent a long time doing this. Pretty much everything I had to learn myself. One thing that I feel like I should mention, I go back to use cheat sheet. When I click the use cheat sheet button, it activates this function and displays the cheat sheet window. So this is all of the code for the cheat sheet window. So every one of these squares is actually a button. I just made it so that if you click it, it doesn't do anything. And that's click null again. So yeah, with that, I think that's about all there is. Make the text a bit smaller so it's easier to see. Give you a bit of a view how much there is. So just making it super small. I'm pretty proud of myself that I did this. It took me ever. You can see just how many lines of code went into those cheat sheet boxes. And this took a long time to type. I did copy paste a lot of this, but even still, the little things that I had to change per line took a long time to type. So yeah, that's it. Thank you for watching. I guess if anybody's interested that's watching this, you can download this. I'll try to figure out how to put it online and put a link in the description for you to download. So yeah, thank you very much.